Variable control chart, Xbar and R Charts. This is chapter 5. In this chapter, we're going to understand the Xbar and R chart and how to build them and how to use them to understand if a process is in control or out of control. So we use the Xbar and R chart when we have variable data that we can measure, we can break into decimal values, and we have a small sample size. This means n less than 10. So how do we build an Xbar and R chart? Well, the first step is to select the quality characteristic. And a quality characteristic must be measurable and can be expressed in numbers. And it can be expressed in terms of the 7 basic units: length, mass, time, electrical current, temperature, systems, or intensity. And as well, it can be any of the derived units such as power, velocity, force, energy, density, and pressure. So once you have this quality characteristic, which you know that is the one that is affecting the performance of the product or service, and you need now to choose the rational subgroup. As I mentioned before, a control chart consists of a group of items, and these items are called rational subgroup. Now, it is important to understand that when you collect data in a random manner, this doesn't mean that this data collected are rational. Okay, so a rational subgroup is one in which the variation within the subgroup is due only to common causes of variation. Once you have chosen the rational subgroup, you now have to collect the data, and it is recommended to use 20 to 25 subgroup samples. And because we're using an R chart, this should be this subgroup sample should be composed of less than 10 measurements. Once you have collected these different subgroup of samples, you have now to calculate the subgroup sample mean and range for each sample. So if you have 20 subgroup samples, you must calculate 20 subgroup sample means and 20 range for that subgroup sample. And the way that we calculate the mean is the sum of those different measurements divided by the sample size of that subgroup size. And for the range is always the maximum minus the minimum value for that subgroup sample. Once you have that, you now have to calculate your center line, which is X double bar for the Xbar chart and the R bar for the R chart. And the way that you do it is for the X double bar, you will take a sum of all those sample means that you calculated in the step before, and you're going to divide it by the number of subgroup sample. In this case will be 20. For the R bar, you're going to sum all of those R that you calculated for each subgroup, which are 20 of them, and then you're going to divide it by the number of subgroup samples, which in this case is 20. Once you have that, you now have to calculate the upper and the lower control limits for both Xbar and the R chart. For the Xbar, the way that you calculate the upper control limit is using the X double bar that you calculated in the prior step plus A sub 2 times the R bar. The A sub 2 is a value that you're going to obtain from a table, and this table is located in your appendix and is page number 5 0.14. This value, the way that you're going to read this value is using the number of observation in a sample. So if you have, for instance, 4 observation in one subgroup, then you're going to use that number 4 and you're going to move to that column where you're going to find the A sub 2 and obtain that value. So that's for the upper control limit. For the lower control limit, it's the same A sub 2, but you have to subtract it from the X double bar. So once you calculate the control limit for the Xbar chart, now you have to do it for the R chart. And here you have to use 2 other values. These are the D4 and the D sub 3. And these values are also found in the same table B in your appendix, page 514. And you have to read the value using the sample size of that subgroup. Having your center line and your upper and your lower control limit for both the Xbar and the R chart, now you have to plot the values. Once you plot the values, then you have to determine whether the points are in statistical control, and you go first on the R chart and then on the Xbar chart. If you don't find any point out of control, then you assume that based on the data used, your process is in statistical control. But if you find that there are some points that are out of control, that indicates that your process might be out of control, so this means that you have to investigate those special causes of variation and then take the necessary actions, which is what we call corrective actions, to eliminate them. Now, in reality, what you will do is you will stop your process and you will try to find out those causes of variation. You will apply corrective action and then you will start your process again. So if you are manufacturing cell phones, you will start that specific part of the process or that process, and you're going to find special cause of variation. Once you apply corrective actions, then you will start your process back again, producing those cell phones. Now, theoretically, what you have to do is to remove those out of control points from your graph, and then you have to recalculate your center line, your upper control limit, and your lower control limit, and graphic again to see if your process is still in control or is out of control. So this is what we're going to be doing theoretically when we work with control charts. Also, this Xbar and R chart, you can have a set or given target value. Okay, when you have the specific target value, you don't have to calculate that center line because that's your value. Now, these are used because and they help because sometimes control charts based on a target value helps to determine whether the existing process is capable of meeting the desirable standards. This is helpful because if a customer is asking for something, you use that as standard value. You will determine if your process is capable of producing or meeting those specifications. Also can help management set realistic goals for existing process, and you could waste time looking for special causes that do not exist if targets are not realistic or based on the process. So having a given target or standard target is also good when we work with Xbar and R charts. So let's work on an example. We have the problem says that the net weight in ounce of a dry bleach product is to be monitored by an Xbar and R charts. and this is using a sample size of n equal to 5. This means that you have 20 subgroups, and each subgroup has a sample 5 or of 5. Okay, so what do we have to do? We have to calculate the average, the mean value for each subgroup. We'll also have to calculate the range for each subgroup. Then with those values, we calculate the center line, which is X double bar for one chart, and the other one will be the R bar value. And then we have to calculate the upper and control limit for both chart. We'll plot the data. We see if the process is in control or out of control. And then we take corrective action if it's out of control. And theoretically, we're going to remove those points and plot the data, or calculate the values again and plot the data again. Okay? You can use Excel, you can use Minitab, or you can do it by hand. So let's start with Excel. I have the data already copied in Excel. So our first point is to calculate the X-bar. The X-bar, once again, is just an average. And we know how to calculate average. We can set the average of this specific road. Okay? You can draw, when you have the cell copy this way and you find, you go to the corner, you're going to find a cross. You can draw all these values all the way down, and this will calculate the average for each road. Okay? So this is our average. You can also go and say that you only want maybe, let's say 2 decimal places. Okay? Now we have to calculate the range, and we know that this is the max value, okay, of this minus the minimum value of the same road. Okay? Once again, you go to the corner, and once you see that cross, you drag all the way down, and it's calculating the average for that. And you can also have, well, you can set it at 2 decimal places as well. Okay? So to calculate the R bar is using the sum, because this is kind of the center line. We use the sum of my whole R column divided by the number of subgroup sample, which is in this case is 20. Now, if you draw this specific cell down, it will not give you the same value because it's changing your cell's number. Okay, so the way that you can just copy and paste it. I want to do a special paste a special, and I want only the value. Okay. Now, to calculate the X double bar is equal to the sum of my X bar divided by the sample size. So you have that. I'm going to copy the value, paste special, and I want only the value. Okay? Then I need to calculate the upper control limit and the lower control limit. The formula for the upper control limit is using it's using, let's see, the X double bar plus the A sub 2 value, which if I go to the table and I use 5, the value is 0.577 times the R bar. And I click enter. I'm going to make this to be 2 decimal values. Okay. Now I'm going to draw to calculate the lower is using X double bar minus the A sub 2 value times the R bar. And I'm going to use 2 decimal values as well. Center this and then draw this all the way. And let's use 3 decimal places. That looks better. Okay. So now we have to graph this R bar chart. The way that you graph it is you have to highlight the X bar column and keeping your finger in the control in your keyboard. You're going to highlight the X double bar, which is your center, the upper and the lower control limit. Once you have that, you're going to go to insert, you're going to line, and you're going to select the first one, which is the one that is crossing. And there is your Xbar chart. You can see that you have a lower control limit, you have your upper control limit, you have your center line, and you have your values. Okay, this is an indication there's no numbers or no points above or below your control limits. Just like that, maybe I can say that I don't see any other type of pattern that will indicate that the process is out of control. Now let's work our chart. So in this case, you find first your range for each of the subgroup. Once again, is the max of this road minus the min of the same road. And you're going to drag all the way down because it must be calculated for each one. Then the X double bar is the sum of all your R divided by the sample size. So I'm going to copy that value, paste it, and do a special paste, and I'm going to use all the formula. Then I have to calculate the upper control limit, and for this case you have to use the D4 sub 4 value from the same table being your appendix, and using a sample 5 of 5, your B4 is D4 is equal to 2.114, and you're going to multiply that times your R bar. Drag all the way down. For your lower control limit, you're going to use D sub 3. And one thing that you need to know about the D values is, or for A sub 2, D sub 3, and D sub 4, when this subgroup size is 6 or less than 6, in this case we have 5, the lower control limit will need to have a negative value. And because negative range is impossible, so the lower control limit is always located at 0. So in this case, O is 0. Okay. So now we have to graphic. We're gonna highlight all the R bar, the upper and the lower. I'm gonna go to insert. I'm gonna go to line, and you select the first one with this is once again using Microsoft 2007. And then you have your lower control limit, your upper control limit, your center line. You see that your points, it doesn't look that you have point out of control. I mean, there is no above or below. And just using the sigma rule that if you have 2 or 3 below or above, 1 sigma, 2 sigma, if just simple that way, it indicates that there is not out of control process here. Okay, you can also use the mini tab, and also I have my data already here. So you go to stat control charts, you select the variable chart for subgroup, and you select Xbar R. And then you have either that all observations for a chart are in a column. In this case, we have observation for a subgroup or in a row. Then you select the different rows. You select the different columns, and then you click OK. There's to have the R chart, the X bar, the R chart, and then you see the same type of charts that we have using Excel. Okay, so once again, the Xbar and R chart is a control chart that you use when you have variable data. And when your sample size for each subgroup sample size is small, and this means equal or less than 10.